Hi, this is King of Review. If A is a square matrix of order 2 satisfying B equals P inverse times A times P, find the element at 1, 1. This means the entry at row 1, column 1 in matrix A to the 4th power. And we're given what matrix P and B are. So let's start with the given equation. B equals P inverse times A times P. Again, remember, I want to get matrix A to the 4th power, so I want to get A by itself on one side. The first thing I'm going to do is multiply by P on the left sides of each side of the equation. So I have PB equals P times P inverse AP. And now I'm going to multiply by P inverse on the right side of each side of the equation. So I have P times B times P inverse equals P times P inverse A times P inverse. So I want you to remember that an inverse, if we have, let's say we have matrix A, and we multiply it by A inverse, you're going to end up with an identity matrix. And if you remember, an identity matrix has 1s in the main diagonal and 0s elsewhere. One feature about an identity matrix is if you multiply any matrix, let's call it A, times an identity matrix, you will get, for the product, the original matrix. This also works for I times A. You'll get A. So I want you to keep this in mind as we're solving this problem. If you notice here, we have P times its inverse. So that's going to equal the identity matrix. And here we also have P times its inverse. This will equal its identity matrix. And because we're thinking about this rule here, if we have a matrix times an identity matrix, the product is the original matrix, we know that we'll get A on one side here. So now we know that matrix A is equal to P times B times P inverse. So now we have A by itself on one side. Now remember, up here, we wanted A to the power of 4. So this means A to the power of 4. This means matrix A, this here, times itself 4 times. So we have P, B, P inverse times P, B, P inverse times P, B, P inverse, and one more, P, B times P inverse. So this is A4 expanded, A to the 4th power expanded. And again, we're going to consider this rule here. If we have A times its inverse, you're going to get the identity matrix. So let's look at this expansion of A to the 4th power. We see that we have P times its inverse, P times the inverse, P times the inverse here. So all of these become the identity matrix, and they drop out. And what's left? Well, P is left, and this very last P inverse is left, and then we have 1, 2, 3, 4 matrix B's left. So let's write that out. So we now know that A to the 4th power is equal to P times B to the 4th times P inverse. So what we want to do is figure out what each of these terms are. We know what P is, that was given to us. So now we need to figure out what B to the 4th and P inverse are. So let's start with what was given here. We know what matrix B is. So what is B squared? B squared is matrix B times itself. So let's set up that. Matrix B is 1, 0, 2, 1. And we're multiplying it by itself, 1, 0, 2, 1. So now we're going to multiply these two matrices together. So again, the format for multiplying is 1 times 1 plus 0 times 2. That will be the first entry. And that gives us 1. And then we'll continue in that fashion to figure out the other entries. So we get 4, 0, and 1. So this is B squared. Now b to the fourth, this is the same thing as b squared times b squared. So we know what b squared is. We solved for that here. That's 1, 0, 4, 1 times b squared again. 1, 0, 4, 1. And now let's multiply these out. 1 times 1 plus 0 times 4. That gives us a 1. And we'll continue multiplying in this fashion. We get 8, 0, and 1. So now we know what b to the fourth power is. Next up, we need to figure out what p inverse is. Now remember, if we have matrix A, let's call matrix A, B, C, D. And if we want to know what A inverse is, we're going to take 1 over the determinant of A, and that's the main diagonal here, the product of the main diagonal, AD, minus the product of the entries in the other diagonal. So AD minus CB. And this is times. Now A and D are going to switch positions, and then we'll take negative B and negative C. So now let's set up what P inverse is. We know what matrix P is here, so we have 1 over the determinant of P, so we have the product of the main diagonal, 1 times 1, minus the product of the entries in the other diagonal, 0 times 1. So this is 1 over, and when you simplify the denominator, you'll get 1. So this whole fraction simplifies to 1. And then we're multiplying it by, now A and D positions will switch. That still leaves us with 1 and 1. And then we're going to take negative 1 and 0. So since this whole fraction here equals 1, P inverse is going to be 1, negative 1, 0, and 1. So now we know this third term in figuring out what A to the fourth power is. So now let's put them all together. We have matrix P, which was given. So that's 1, 1, 0, 1 times B to the fourth power. And we figured that out up here. That's 1, 0, 8, 1. And then P inverse. And we figured that out here. That's 1, negative 1, 0, and 1. So now what we want to do is multiply this out. We're going to start by multiplying this portion out. So that will give us, when we multiply those first two matrices together, we're going to get 9, 8, 1, and 1. And then we still have to multiply it by that third matrix, which was the P inverse, 1, negative 1, 0, and 1. And now when we multiply that together, we get A4. Matrix A to the power of 4 is equal to, we get 9, 8, negative 8, and negative 7. So now we've figured out what matrix A to the fourth power is. And again, we wanted to find the entry that's at position 1, 1, which is row 1, column 1. And that's right here. And that's a 9. So 9 is the final answer. Thanks for watching.